Welcome to the session on creating a data sharing cloud on Drupal 8. My name is Amit Chaurasia, and I'm presenting this work which is done at my institution. And I wanted to acknowledge the middle author there, David Nadeau. This is principally, he is the principal contributor on this work. And so this is a fairly big effort which has been going on for some time now. And I'm quite excited to kind of share this with the Drupal community, because I think it's at the time where people can get an early idea of what this is about before it shows up as a stable module. And of course, we need some help getting there. So about me, I am a researcher at the San Diego Supercomputer Center. I also teach once a year. And my interests are in high-performance computing and computer graphics, and now also in data stewardship. And these words may mean different things to different people, but in this particular talk, we are going to focus a little bit more on data side of things. My connection to Drupal, I've been using Drupal for about a dozen years. I've built sites from scratch, starting from very early versions of Drupal of varying degree. I still run my personal site on Drupal, which is fairly small, but now it runs on Drupal 8. Started on Drupal 4, went through 5, 6, 7, and 8 now. So we've been a kind of interesting journey there. But on some other interesting sites which I've worked on and developed, they have been pretty interesting as well. I created a site on Drupal 5 which has 50,000 nodes. So that was pre-services date. Everything was kind of hacked in, written in PHP to kind of glue the nodes together. You're not going to hand create 50,000 nodes. So that was interesting. On Drupal 7, we run sort of a previous incarnation of what I'm trying to present now. And that's been used by researchers around the country, actually around the world. A few hundred researchers, not a very big community. But it's used for video encoding. So I work in visualization. We often create series of images as a result of creating visualization process. And these images need to be converted into a movie. And that process is lossy, and you need to learn too many things. So we created a service where people can upload their images directly from the supercomputers and share it with anyone, right? So it's all command line based, but of course you can do things through the web, and it's on Drupal 7. So this has over 100,000 items right now, actually nodes. Actually, all of them are images, right? So this is a lot of content. This stuff, which we are going to present, we are expecting that we'll manage more than 1 million items with this sort of thing. So we are looking forward to kind of, having this kind of worked out and released to the community. Also very interested in finding PHP programmers. If there are any interested in working with us, please do let me know. We want a person who has kind of very good knowledge of the core, because this is ultimately a virtual file system. So we go quite deep into the Drupal stack. Actually, we hit the bottom actually in this case, right? So having good knowledge of core is something which is very desirable. So this is what the talk looks like. I'm gonna go through a lot of things in between why we are doing this, more importantly, to begin with, and then end up with a demo. Just to give you a background from where we are coming from, our project is called SeedMe, which is Stream, Encode, and Explore and Disseminate My Experiments. Contrived name. Hard to find 6-letter domain names, but I did, so that's why it's named like that. In this particular case, like I was mentioning, SeedMe 1 was written for video encoding purposes. And when people started coming to us that, hey, we like it, can we have it? It was not meant to be given away. And SeedMe 1 made some assumptions about, kind of similar to what Drupal does, is everything is flat, right? You go to an article, it's flat. There is no notion of folder and file, which is how people organize normally their data. And so a hierarchy for a data management point of view makes sense, because that's how we keep things. And that was not really there. So we started afresh. And while we are beginning the project, Drupal 8 was just around the corner. And so we decided to base everything on 8, because both systems are not API compatible. So that's kind of the lineage of this project. Our focus for the SeedMe 2 project is to enable rapid access to data. I work with a lot of researchers who basically compute all kinds of things on the clusters. And very few people may have access to a big machine. So I have worked with people, like 30 or 40 people, only 3 of them have access to a super. And well, how do you give content back to them? So we do it, we download it, we set up websites. I did this all by hand, hundreds of web pages, hundreds of images, hundreds of movies. It becomes very taxing. So that's how kind of the project originated. Also, we want to actually target consumable data because supers can generate a lot of data. Obviously, all that data doesn't belong on the web, but at least the consumable data belong on the web, right? So the idea is if something that is easily handleable, you can download it on the web. I work a lot with earthquake simulations. The one file is 160 gigabyte, right? And they have few million of those. I mean, what am I going to do downloading it on my desktop to begin with? But when we create visualizations, well, those are usable. They can come on the web. They can be displayed on the phone, and they can be distributed, and so on and so forth. Same thing goes with analysis and things like that. Small files, small products, well-distilled products, they can be consumed by anyone. And so that's the idea. And so data management has many issues. I'm sure you guys see some of these, at least. And, as researchers, we solve them in many ways, and, it works, right? However, you can say goodbye to presentation and discovery, right? And that's what happens on cloud drives, right? When you move things and put a folder on a Dropbox, it works for that period of time, but when you go 3 months back later to figure out where is what, especially as a collaborator, not as a person who put those things there, it's very hard to know what the context was about. Then you go search through the email what this was about, and good luck tying things together. And in research world, we deal a lot with data. We produce data at a non-stopping pace, and we have to go back and forth. And those things become very hard to track just by file names or folder names. So file system, while it's kind of a nice thing, it's not necessarily sufficient to kind of managing data. Furthermore, on the same spirit, I like to think that data is not just about files and folders. There is a context about the data, which I call description. And there is some discussion about this data, which happens through emails. So data lives somewhere, maybe on the cloud, description lives in somebody's mind, and discussion lives in emails. And when you have more of these things, it becomes really hard to track. And so if we can co-locate these things together, we can actually minimize that pain quite a bit. So we are not the first one to think of this sort of thing. There are many things which are out there. Most of them are file system based, and they work quite well. However, they suffer with the same problems I was mentioning about description and discussion and ability to add other information to it. There's a new class of stuff which is emerging which uses content management systems, and there are a couple of systems out there which try to do something similar. However, they all suffer with some sort of limitation one way or the other, and that's why we built this thing. So this is the workflow which we envision for the kinds of things which we do. Of course, this is going to vary for many of you folks. The idea would be, you sign in, create a project, create folders, put content in there, add descriptions, share it, right? On the other side, consumption side, you should be able to view it, search it, download it. And since this is web-based, it should work in all 3 interaction modalities. It should work through the web browser. It should work through the command line, because we are on supers, there is no browser there. And it should have an API, not just a REST API, but an extensible API at the file system level, so people can write plugins and things like that, right? So that's kind of the key requirement for this sort of thing. In terms of architecture, nothing out of the ordinary here, just a standard Drupal, and we want to plug in this functionality with some modules, right? Now, there are a couple things which are in addition to Drupal. We looked at PHP's CSV parser. Turns out it only does simple parsing. It breaks for most of the things, so we wrote our own. We hope to contribute that back. And we want to write some other modules for visualization of structured data. I'll show that to you in a minute. And then, of course, we want to write command line, which people can run. And then, of course, REST clients. We don't want to stop at writing an API. We don't want developers to write a client. We will provide the client. You just use it, right? Of course, if you want to write your own client, you are welcome to. But we want to provide that client in PHP, Python, Java, and if somebody twists our arms, also in C, right? But C is not a priority right now. Okay, so let's look at the Foldershare module. It's one thing which we consciously decided that we will not depend on anything in contributed land. That doesn't mean we'll not extend the functionality with that, but our core module will only be core compliant. And so currently, the module depends on 11 submodules, which are all in core. There are a few optional things you can enable, like comments. Everyone doesn't need comments, but if that makes sense, well, you can enable that. It's an optional thing. Similarly, all the services need not have command line access. That means you don't need to worry about REST. You can disable that, right? So all those things are optional. The couple things which we think are quite nice, like the real name module, when you have a file or a folder, it's owned by somebody. If it shows a name of the person, it's much better than the username from a usability point of view. So we think that a couple of other modules can help us here. But again, they're optional. Also, turns out that the REST module, most of the stuff is in core, but turns out to manage all that stuff, you have to use a contributed module, which is kind of strange. I hope that this makes it into core, but it's not required. So in essence, the Foldershare module actually is a file system underneath the hood. It has its own entity type. It has access control built into it, like any file system would. It tracks what is being used by whom. And then, of course, any file system has to have a metaphor for displaying content, which is done through views and a few other things. And then any file system would have operations like copy, move, delete, compress, things like that. All those things are implemented as plugins. So the idea there is we ship the core set of plugins, but then somebody wants to extend that. They write that plugin according to the API, and that plugin now becomes available not only at the back end, but also at the UI, right? So everything is pluggable, right? So one example would be compress. So you have a bunch of files, you select them, and say, hey, create a zip archive out of this. Well, that's a plugin. We already shipped that, but that's kind of the idea. Files and folders. So like in any file system, the parents, the folder and files always know who their parents are, right? That's what a hierarchical file system does. In our case, we do one more thing. Every child or a grandchild also knows who their root is, right? What is their top level ancestor is. So we keep track of that. And we do that for a reason. So before we talk about that, the file storage and the file system is abstracted. That means what a user sees is not on the file system. Folders only live on the database. Only files get stored. There is no reason for us to store the folders because they are just placeholders. And there's also, if you're building a data sharing sort of stuff, well, we cannot live with the limitation of only PNG and text files are allowed as upload. You have to support arbitrary file uploads and secure them. And once you do that, you have to carefully manage all that stuff. So internally, when the files actually hit the file system, they don't retain anything. We enumerate them. They have machine-generated names. The usernames live in the database. So when the user sees them, they get them back. But on a file system, they are all abstracted out, right? Also, the hierarchy which a user sees is not how it's stored on the file system. And there are reasons to do that, not only from a security perspective, but also from a file system performance perspective. On the supers, we deal a lot of problem with if somebody creates 1 million files in a folder, the file system hangs, and then the machine dies. And most of the file systems are not designed in a way that you can put 1 million files or more than they may be, Once you do 20,000 files in a folder and do a LS, your machine will start to kind of show some signs of strain. Not a big one, once you keep increasing those size files, it'll keep getting worse. So how do you avoid that? Well, you can train your users to say, no, don't do this. Well, good luck with that. So we abstract all that stuff, right? So one way is to hide it. You don't let the user do what they need to do, but you hide all that stuff. So that's how we hide all that stuff. Currently, we implement the file system as a bit pattern. What essentially that means is, we will create 4 hierarchies. There's a top level folder called 000, then there's a subfolder, and that hierarchy which you see. Every subfolder in our tree can have, about 10,000 files. So once you add all that stuff up, you can potentially manage, about 500 million files. Many things are going to break before that. So, maybe we can add another layer, but probably that's enough for now. So that's the idea that, we can reach quite far in terms of file management. I was talking about every child or a grandchild knows what their root parent is, and that's done for access control reasons. In our case, we looked at all the cloud drives like Dropbox, Google Drive, OwnCloud, this and that, and tried to figure out how are these different cloud drives implementing access control. And one thing which we found commonly was being used that the access controls live on the top. So if you create a folder, everything inside it has the same access control. It's not recursive access control which you see in a POSIX file system or on a Mac, right? Which is nice, and we chose to keep that metaphor of keeping the access control on the top. It simplifies things. It also is due to performance reasons. On your disk file system, the metadata or the permissions live on the disk, which is very fast to access. In our case, everything lives in MySQL, and every time you're going to do a query, it's going to take a performance hit. So if you're going to recursively compute permissions, it's going to slow down the entire thing. And this is all based on web, and you don't want the user experience to be really bad. So we simplified all that stuff, and we keep the access controls on the top. The side effect of that is, entire tree is shared, whatever you choose to share it with, right? So if you cannot say, oh, my grandchild needs to be public and rest of the tree needs to be private. Well, if it's public, it needs to move to a new folder. That's the way it's implemented. So that's the limitation right now. File storage, I already covered this. The only thing to remember here is that the files are not stored in the same way as a user sees. There is a machine-generated way to store them. And, of course, because of that, we not only have better performance, but we also kind of, get rid of some of the security issues that your server can execute some files or something like that, right? Presenting the stuff needs to be done in some way, and usually, you see a tabular listing of your files on your operating system. We want to mimic that, right? And so we do that through views. This was extremely hard to implement, but we were able to do that. And then we want to kind of, have a user interface which mimics the operating system, meaning that when you select files, certain operations become available, and when nothing is selected, other operations are available, so it's context sensitive. We also want to follow the web conventions, meaning everything must work without JavaScript. Well, JavaScript is nice, but not necessary. So we implemented a UI. Underneath the hood, the UI is implemented like that, and you'll see that. We don't have Ajax and JavaScript in this particular version, but it's coming. Plugins. When you kind of have any content, you obviously want to display it in some form or a fashion. Everything should not be displayed as a link. So for example, an image should be styled, right? Image should be visible. It should not be just displayed as a link which you download and then see. So anything displayable should be displayed. So images are displayed. The same idea would go for videos. They should be formatted to be playable instead of, old school way of downloading things and playing them back. And this idea can be extended to other things. In research, we have all kinds of data, and there are different kind of formatters. So for example, if you were working with protein structure, well, if the protein structure is not too large, we can display it in 3D using JavaScript. So somebody can write a plugin, and when you look at that file, it can be displayed. The idea is not to enable necessarily exhaustive scientific analysis, but to give a preview of something, what this is about, and then they can go about doing their work. So all these things are implemented as plugins. Searching, this is another important thing, that when you put content into the file system, it should be searchable. And so the entity has a notion of search. If the search module is enabled in Drupal, it will index everything, and it will be searchable. Drupal search is arguably quite weak. That's what we get out of the box. So we are looking at other plugins, which will be obviously optional, which can do better searching, because the Drupal search only does keyword match, and it's kind of limiting if you want to search for a file, and you don't know the file name. Well, good luck. It's not going to find it because the Drupal's search mechanism doesn't have a good stemmer or something like that. So we are looking at ways to kind of extend that sort of thing. Actions and custom commands. I mean, this is fairly simple idea that any operation on a file system like copy, move, share, all these things are actions which a user can take. The idea should be that somebody should be able to add on to this. Not sure if I should show this slide, but here is a kind of trivia about how this module compares with the Node module, which ships with Drupal core. This is, at current time, this is twice the size of the Node module, and it's growing. And we had a very difficult time implementing this functionality in Drupal core because we found that the documentation for Drupal core at the lowest level was pretty dismal. So we had to read the source code to figure out what's going on. So that slowed our progress. So we decided that we should not do the same thing. Our module is fairly well documented. If you see that purple line, we have more than 2 lines of documentation for every line of code that is written. So we are trying to leave the place better than what we found. So this is a fairly big module. That's the one takeaway. And so to show you that I'm only not saying, there is the API documentation which gets generated. Interestingly enough, you need Drupal 7 to generate Drupal 8 documentation, because the documentation module is not stable, or probably. I wonder if it'll ever get to port it to Drupal 8. That's okay, I think it doesn't matter. Then we have another module in an API called SmallData. This SmallData API is a PHP module which basically parses CSV files and converts them to JSON back and forth, right? And the idea was we found that the PHP's parser was limiting, so we wrote our own. And the reason we needed to do that was we often find structured data in form of CSV files. People write, do their simulations and say, hey, the energy convergence was this, which is often written as a CSV file. And CSV files are very common anyways. So the idea was that we look at our usage pattern. People would create the CSV file, download it from the supers, and then they will plot it in Excel. Well, what if we just plot it right when it's uploaded? So we created a visualization module which parses the CSV file, builds up a semantic structure about it and creates a visualization. And so we'll show that. It's not very intelligent semantics, but we do some. So you'll see an idea about that. From an administrator point of view, if you're a site builder, obviously you want a great deal of content control over how people are going to use your site and your storage, which comes with it. All that is actually available in module settings. The folder share configuration comes with customary manage file, fields, and manage display, as you would see in Drupal for many entities. It's there. So the folder share entity is fieldable. By default, it has a notion of folder name, file name, and attaching files and things like that, but it's extensible. You can add tags, you can add taxonomy, you can add other fields if those make sense for your use case. We only ship the stock thing ships with a description, which is kind of the notion of old way of Node, that the Node always came with description. We bake description purposefully into this file system because we think it's important to retain the ability of an explicit way or an implicit way to describe content. If you don't describe it, it looks like DropBox. But if you do, then it becomes searchable. So we bake that thing in. It's not optional, at least at this time. Then since you are going to be doing data sharing, it's important that the access controls are followed in a way that they meet the access control capability which the system provides. That means where are you going to store these files ultimately on a file system? Drupal allows you to store, has two file system notion, public and private. If data sharing is important or the access control is important, then this the files better be placed in a private file system, because if you store them on public file system, while the access control will work through the Drupal website, but if somebody knows the right URL, they can get to it without any access control. So that's kind of something which needs to be thought carefully. If those access controls are important, the file system should be chosen as private. We don't make any assumption about it, of course. There could be some good use cases when public file system is just the right way to do things. There's a public repository for, let's say, crop genome, right? There's no need for access controls to be there because it's public. And so putting that sort of stuff in a public file system is a fair thing. But on the other hand, if something needs to be private, that needs to be on a private file system. Similarly, by default, the module will allow anybody to upload arbitrary files. But of course, there may be use cases where you want to limit that and say, hey, I only want 10 kinds of files to be uploaded. So that option is available, and administrators can configure that. I think this works better if I show this to you here. So enable restrictions. So there we go. So we did a search of what's can be there, right? But of course, this is kind of going out on a whim and putting these things in, but you can restrict it, right? But by default, this is not enabled. Also, you want to control how big a file can be uploaded. So those things are there. There are some PHP limitation. I just learned in core that something is coming in 8.6 which will do chunking. So if you are gonna allow, if you need to upload a file, let's say 2 GB, and your PHP settings only allow 100 MB, it will do chunking. So that was on our list. I'm glad core took care of it, so we don't have to worry about that. Okay, so let's go on to the next one here. Menus. Like I mentioned, all these things are implemented as plugins. For some reason, if you think something should be disabled, the administrator has control to kind of, remove some functionality from the get-go. Views, the display of the file system is controlled by views. You can go and change things. Let's say you want to hide some column or add some column. That's why we use views. Actually, we pay a little bit of performance penalty of using views, but that's the only way we can extend the control to somebody else to display things which they want to versus not. For some reason, if the displays get messed or the views get messed up, you can restore them from here, right? Because the view setup is fairly complicated, and it can, there's a chance that they can get messed up. There is also some security. For some reason, you don't want to enable sharing, you can disable it. For some reason, if you don't want the data to be available to public ever, you can disable that too. So all those controls are baked in. Finally, if your serialization and few other modules, you want the REST service to be up, there's no configuration required, but if the other modules are available, the thing can set up at the installation time to enable the web services by default, if those things are enabled in the core, or your instance for that matter. Okay, so let's look at, so I covered this is from an administrator point of view. Actually, there's one more thing. So as an administrator, you'd also want to see, who's using how much, right? So there's a reporting mechanism which will show you who has how much content, right? Later on, we'll develop a module for policy and say, hey, people can only use 2 GB of storage, right? You don't want the users to use more than that, so we can write a module for that. For the sites who want to kind of enable that, they can do that sort of thing. Okay, let's go here. When you install the module, it obviously comes with some permission. In this case, the permissions to care about are who can see the files which are uploaded. If you're going to be, making things available on public, it's a good idea to give anonymous user a view access to the file. Who can create files? authenticated users typically would be given permissions to create files. There's another use case of who can actually create top-level folders. And the idea here is normally you'd give it to all authenticated users, but there may be some use case that, let's say, you want someone to kind of edit or contribute something which you are working on, but not start to use your site as their data sharing repository. In that case, you can control and create a role and say, hey, these guys are collaborators. They can put in stuff, but they cannot start to use our site as their collaboration mechanism. So there may be a use case like that. And of course, who can administer the module and things like that. For users, this looks fairly similar to kind of a cloud drive notion. There's a tab that says personal. Anything that belongs to you will show up in the personal tab. Anything that is shared with you will show up in the shared tab, and public content on the site is on the public tab. Notice this is what you don't get on a cloud drive, an ability to describe something. You are no longer limited to a file name or a folder name. You can describe that content, that, hey, I took this picture in Nashville attending DrupalCon, right? That may not be important for the file, but it is important to humans, what's going on, right? So this kind of thing arises with researchers all the time, what the simulation parameters are, where is the output stored, where is the input stored, all that meta information is there, but I cannot dig 20 files to find that out, especially when you're working with groups. So you can describe all that stuff, whatever is meaningful, you can describe it. Another example may be, hey, there's a logo design going on. What changed in this logo? What is the theme we are going for? What is the concept? Now that is not traveling through email, it's right there with the logo image. So that kind of thing can happen. Of course, you have a menu. It says, hey, what can you do with it? Give you all the options. Nothing is selected. It says what operations are available. When something is available, like your operating system, the menu is context sensitive. So when you select something, it shows different options. When nothing is selected, it shows different options, right? Nothing out of the ordinary. Sharing. This is the main part why this virtual file system was created, is who can do what. So we implement 3 permissions. One is, by default, everything is private, right? You can give view permissions, which is read permissions to anybody. And you can give write permission, which is author permissions to any user you choose. So this is already up and functional. So this is what a folder looks like, right? You see a tabular display of folders and files and a few columns along with it. You see there are 2 users. That means somebody can write to this folder. It also says shared next to it. There's a breadcrumb which shows where in hierarchy you are in. And of course, the description, it only shows you teaser whatever you configure in views, but of course, the description can be anything in HTML, whatever you allow. Again, description. And again, like I mentioned, this Foldershare entity is fieldable. So we can wire in comments now and enable comments at a folder and a file level. If people want to use that, they can enable and disable comment as they see fit, right? So it's, of course, this is not only limited to comments, but you can add tags, taxonomy, or whatever makes sense for your use case. So I was mentioning about visualization. So when you upload a CSV or a JSON file, the parser would parse the file and try to build some semantics. Oh, this thing looks like 2 columns. Maybe a line chart or a bar chart would be appropriate for this sort of thing. So here, let's see an example of a CSV file, which is highlighted. This is what happens by default. It creates a bar chart, right? And for some reason, it will probably not get the thing right. Maybe there should be a column chart or something else. But those options are available. So you can switch it to a line chart or an area chart, or you can just display it as a data, right? So if that makes sense. So this is out of the box. The idea is not to create the best visualization. The idea is to give a preview, right? And so, like I mentioned, this thing should work through all modalities, and command line is one of them. And so we have a client, PHP client, which works like a Unix utility. You can, it has similar commands to like POSIX file system. You can list files, you can make directories, you can upload content. We made up that upload command because there's no such command in Unix. But there's put and get from FTP era, which are also kind of synonymous to that, so they are there. You You can upload files, download files, of course, remove files. So from our perspective, we have many classes of users who may find this thing interesting and useful. There are researchers themselves who want to use it as a collaboration website for their projects. There are project repositories, like I was mentioning, crop genome, and there are different kind of data banks who kind of just use a very limiting file and folder system right now to display and share their content. They can benefit from a richer way of kind of sharing their data with metadata and things like that. So they are another class of users. We are also thinking that, and we already have some commitments from scientific applications who want to integrate this sort of functionality, like you see something like save to Dropbox. You can have a similar functionality built into an app and say, hey, save to my website, whatever that website may be. And the idea there is once we provide these Python and Java clients, it's pretty easy to kind of wrap them up. And Meg is here from Lawrence Livermore, and they have a fantastic tool called Visit, and they already have something called Save to SeedMe 1. So, I mean, there are a few other applications which already use the first generation version of our project, but the idea is now their tool is dependent on our service. In this case, we can say, hey, you can just spin up your stuff. And that sort of thing is available. And I think there is a lot of power in user-generated content from an application developer point of view. This gets lost right now, especially in research world, because as a researcher or application developer, you can only create so many kinds of examples. But if your researcher starts to contribute and say, hey, this is the way I'm using your tool, by the way, and here is a reusable template, this is the way I'm doing it, then that library starts to grow. Other people can reuse that content. So there are some very interesting use cases in terms of dissemination and training and so forth. I think this is a different sort of crowd here. You probably never heard the word science gateways. Just to kind of give you a glimpse of what that may mean. So there is an increasing notion. Most of the time, people use the supercomputers by logging in SSH, this and that, running tools, compiling tools, and all that stuff. That's pretty taxing and boring and cumbersome for many users. Another idea has emerged as creating a web page where people can submit their job and say, hey, I want to run kind of a blast algorithm or something like that. There are 5 or 6 functionality which the web page exposes, and say, here is my input, run this algorithm, and when it's done, let me know, right? And so this sort of thing is happening in many domains. And we used to have few hundred users till like 2007 or something like that. Right now we have tens of thousands of users just because of that. Most of our users are coming through these proxy websites which allow you to do very domain specific things. And I think our machine right now, we have a mid-sized machine, which is not big, 50,000 cores. Half of that machine is used by these sort of things all the time, 24/7, 365 days. So these kind of discipline is kind of broadening the access to very good compute capability through a website, right? So those people actually who have developed this sort of website, they can do the compute part, but they don't have any data sharing. And so instead of building a solution, they can kind of benefit from this sort of stuff that, hey, you do the compute here and also share the data. And then also what we call cyber infrastructure providers, which is a fancy word of saying IT providers. People can set up website for research faculty or your groups who can kind of benefit from something like that. So just so you know, I'm not making all this stuff up. Here is a group of physicists who's using this stuff. And they can't write equations in email, by the way. It doesn't work, right? So here is a good example why description is very important. It needs to show up where the content is, right? And so here is a folder, and they have a bunch of content. And they really wanted to write their formulas in LaTeX. Is anyone familiar with that? All right, couple people. All right, so LaTeX is a special way of writing or writing markup to generate PDFs. So a very old school way, but very powerful. Turns out, I said, okay, I don't know, our module doesn't support all that kind of stuff, but let me look. I found the MathJax module, which is stable. I installed it and enabled it in CK editor, and boom, they can write their equation, and they are so thrilled with this thing. So they would have, for every group meeting, they would have PowerPoint presentations because they can't write equations on email. And every time somebody would come up and talk, they would have PowerPoint presentation. Now they just click a link, and they're talking about this stuff, where their content is, where their data is, so they are not creating all this PowerPoint thing at all. They've just switched. So they have, most of the people are in one place, but there's one collaborator who's in Japan. And so, you know, it's working out quite nicely for them. So with that, I'd like to welcome you folks to try it. If you guys want to do kind of installation and things like that, alpha version of module is available on GitHub. You can find it also through the Drupal page. But if you just want to play with it, we have created sandboxes. You can go to that website. You can just spin up a new instance. It will get deleted in 7 days. You can spin another one once that's done, and you can just play with it. It doesn't come with admin controls, but if you need it, just send me an email. I can give you admin privileges. But it gives you kind of a middle-level privilege, which you can see the module configuration and something like that. So if you need something more persistent, let me know. I can help you there. And with that, I wanted to acknowledge my team lastly, who's doing bulk of the work for putting this together, and also the users and other developers who have given us feedback over the years to kind of get to where we are right now, and also to our sponsor, which is the National Science Foundation, which is funding this work. So I can show you a very quick demo because some of the things actually make sense a little bit more with the demo. I don't know how we are doing on time. Are we? No, I think we have time. Yeah. Okay, perfect. So let's go here. So here is, go here. Let me show you the visualization stuff real quick, and then I'll come back to it. Not that one. That one. Okay, so here is a CSV file, similar to what I was showing. If I click on it, this is what happens, right? I can switch it to different representations. And then notice there is a ability to describe something, right? This is all bogus, but the idea is your description can be next to your file or your data. Let me show you a little bit more interesting one. So here's a benchmark. Of course, you can switch it. And so right now, this is using Google Charts, but potentially we can switch the visualization engine to be D3 or something else, or high charts or whatever.
So Google Charts comes with it, or you have to enable Google Charts to get this?
You don't have to enable anything. It will just go and talk to, so if you have a firewall, and because it downloads the, I mean, we haven't gone through the effort of kind of localizing everything, so it does talk to the CDN right now to get the library, JS library, but potentially that could be localized, yeah.
I can install the library on our yellow network, for example.
Oh yeah, for your case when you have a DMZ or something, uncontrolled network, yeah. So yeah, we are not there, but I think ideally what we should do is when you install the module, you should be able to kind of fetch the libraries, install it, so then you don't have to, go and, have a network issue. And then just to give you an idea here, here is a JSON file, which is a tree, right? This is not tabular, so line chart doesn't work, bar chart doesn't work. So our module basically has some built-in semantics about what works with what representations, and that's what it does. So right now we don't have any other representation for a tree data. This is what you get. Potentially it could be a network diagram or something like that. So we can expand upon that at a later time, but it's kind of give you idea of how you can think about writing plugins or, displaying some data which may make sense. Not everything needs to be displayed, but some of the things may be useful. Okay, so let's go here. Let me show you a real quickly. So let me grab this. So I can select multiple files by just clicking on the rows. Let me just delete these items here. Or we have some issue with this white screen going on. We'll fix that. So let me create a folder here. So a new folder gets created. There it is. If I go inside it, I can go and say, hey, upload files. And so I'm going to upload files. So I can select multiple files in there, and they get uploaded. So there they are. Notice there are some fake files, PHP, Python, JavaScript, which will normally Drupal will scream at, and so they can be uploaded. When you click on them, you go to that thing, and all you can do is download it. But the idea would be we can write a file formatter which displays it as a text, right? So you can see lines, whatever the content is, right? So that's the idea. Now, of course, here I can select multiple files and say, hey, compress them. It will create a zip archive. Or you can just download them. Here is the zip archive. Everything gets named archive.zip. Once you create more, it will just enumerate them, archive _1, 2, and so forth. And of course, if you want to download all these things together, as you would expect, it will zip and download all those things. So all that is already functional. So there we go. So that's that. If I just unzip that, you can see all my files are there, right? So nothing out of, okay, we have some issue with this redirect thing. Getting stuck there. Sharing, actually, so that's something. So here, let me actually create a new folder here first, and then show you sharing. Okay. So I created a new folder. So notice I'm inside this new folder now, which is a child of something, right? I can say, hey, this thing needs to be shared with. Notice it already came with sharing, which means it already had some, because sharing, like I mentioned, is from top level. But I can access the sharing menu from anywhere on the tree. Okay, so I don't have to go back up on the root tree to change the share settings. I can access the share setting at the top level or anywhere in the hierarchy, right? So it had this share settings, and I can change the permissions to, make it publicly visible now, and, give a couple of the users a view or author access, and that's it, right? So here we can see the breadcrumb showing where in hierarchy we are. Actually, this is where the sharing is being changed at the collection level, right? So this is the root folder. Everything inside it now has those permissions, essentially. Yeah, that's about it. So, you can do all the things that you would expect in a file system, right? Create multiple folders, move things around, copy things around. All those operations are already working. Right now, it's a little bit annoying because there's no JavaScript, so you have to go to a different page, but then all these things will start to show up as modal in the next version. One, you would expect a drag and drop sort of thing that's coming. We are testing some things. Not only you should be able to drag things onto the thing, but you should be able to drag them out, which is a little bit difficult to do, but I think we have a good solution there. So we are working on those kind of things. So, that's about it. Again, want to give a shout out to the CI logon project. Any of you work with single sign-on kind of thing? Yeah. With universities? So single sign-on, actually, so this CI logon project provides a single sign-on services for generally research organizations, but also now to commercial ones, which can basically, you can tell them that, hey, here's my server keys, and install the OpenID Connect module for Drupal, and say, hey, please provide access to, these entities who can use my site. So the idea is not everyone needs to log into your site or register. Now they can use your institution credentials to kind of just get going. So we use the service for our first version of the project. And we have about 2,500 organizations around the world who can use my service without any registration. So, of course, I disable Facebook and Google authenticators, but if that makes sense for your site, those can be enabled. So that's kind of a very nice thing. Again, I welcome you all to kind of, play with this project, see if it makes sense. However, I want to caution, this is an alpha level project. It may look like production ready by Drupal standards. It's not. We are changing things. And in fact, just this morning, we changed something in the data model, and we don't want to spend time in migration. But at this time, we are very interested in kind of, opening it out to the community for at least just kind of banging it as a test level stuff, right? And you know, the more help we can get here, the sooner we can become production. Because one caution here is this is not your vanilla module where nothing will get lost. We'd want to absolutely make sure that we don't lose files and things like that. And while we are fairly confident the way things have been written, but we don't know what people are going to do and how they are going to configure things. So I think here we can get some help with the community, wider community who can kind of, you know, play with this thing. Yeah, and, you know, give us some feedback. So I actually also created the module page on Drupal website. I did not know I could do that. So we spent a week conforming to Drupal coding standards and this and that earlier in the year and gave up because we had pressing things to do. Turns out all those things are written, but they are not necessarily required. So I created a stub module. It still points to GitHub, but you know how to discover it. So once we have newer version, we'll start to post it on Drupal.org. But very keen to hear from you folks. Try it out, and yeah, let us know what you guys think. Again, customary slides, which DrupalCon is asking us to kind of mention, the sprints, which are happening on February, and also a survey. What do you think about this talk? Hopefully I'll get to see that. So, yeah, that's it.
Great, thank you.
All right, so we do have time for some questions. All right, I bored you guys to death.
If we do have feedback and just general bug finding, how should we do that? Through Git or through the
Either would be fine. Right now everything is on Git, so it would be easier if you just post it on Git. Yeah. And once you move to Drupal, then Drupal would be better. Yeah.
What's the actual disk file system that these files are being stored in? Is it just whatever your server is using on your hard drive?
Yeah, whatever you specify it to be.
Is there any thoughts on moving that to a cloud-based system?
Currently, no. But I don't actually, we just had an issue. We just threw away our stream wrapper stuff. That's what I was asking at one of the sessions earlier, because we had everything working with the ideal way with the stream wrappers. Turns out image module doesn't like it, so our image style, we're not getting styled. Drupal modules have some assumptions, and even though, you know, Drupal 8 is trying to move things to a more modernized API, so we need to work with the constraint which Core is providing us. So we had to throw away the stream wrapper, but actually it was not even the Drupal's thing, it was GD. You can't change GD. So GD only can style things when it knows the path. It has no notion of stream wrapper. So this is not Drupal, but underlying utilities. So we just tossed away our stream wrapper, which is a lot of work to engineer, but then we cannot assume that, you know, something would come up and use. So potentially you could use Cloud Drive or something like that. I mean, if you have kind of, if you set it up on your server as an NFS file system or something like that, I mean, then it's just straightforward, right? I mean, there's no difference. But yeah, I think that is something that needs to be looked upon once we finish the core. Also, I think there is an issue about S3 sort of stuff. Our focus is more on access control. Once you put things in S3, you have to be careful whether that bucket is not exposed in any other way. So it simplifies something, but it adds many challenges. So something needs to be kind of, I mean, most of the time it doesn't matter. Actually, that's what you want. You don't want to be serving files from your simple box or something like that. You want the CDN capability, and that use case is what you know, most people use. But if you want to do control, well, there better be no other way possible to get to that content. And I'm not familiar at this point whether S3 can be locked down. It better be, but we haven't looked into those things yet.
You've had supercomputers
Yeah, well, we do, because our supercomputers are not available, accessible through web, right? So that's why, that's the reason why we are doing this, because, like I said, I'll give you an extreme example. I was working with the team which was doing earthquake simulation at another lab, Oak Ridge National Lab, and the simulation was going to use 250,000 cores. And we get like 2 days on that machine to run our stuff and get the hell out of there. And so we were doing that. Only 3 people had access to it out of the 40 scientists. So all the computer guys were kind of doing the stuff, but the scientists were waiting for the results. And so we ran it on the machine. The simulation, generates about 1 petabyte of data. And so, my task comes in, I do the visualization, I create the images and, download them, several gigabytes, and create movies, and then create web pages, and then give it to the 30 scientists, and then they say, your movie doesn't play back on my device, right? And so this takes a lot of time, and I think in that case it took about a week for me to give the content back to the scientists. Of course, they do some checks and things like that, but then they had 1 more day to use that big machine. So they cannot validate everything to the, to the level of content they want to use before they can run yet another simulation, because, the policies are such that, you're going to use a big machine, right? 250,000 cores, you only get 1 time to use probably in your lifetime, I guess, at once, right? So you run the simulation again, and then the whole thing begins again. So there is a huge problem in our community that we have these great resources which scientists are using, and they work quite well for many problems, but data sharing is not one of them. And so we want to actually target the consumable side of things. We don't want to target, the terabyte-sized data sets. We want to target things which the scientists want to see, because, they are not going to play with the raw data over and over again. And even if they wanted to, they have to use the supers to begin with. But whatever they create from it is very useful for a lot of people, and that sort of thing is very important. And that's why the command line stuff is very, very important, because people should be able to use all that stuff fairly easily. I can show you a quick video of what this simulation was like, right? So here's our earthquake simulation, right? So this is what we produce on a supercomputer. So it's a big earthquake which is simulated in California, right? And what may happen, right?
And for you.
Yes. So, these are the things which scientists want to see as a product, and they should be able to review it. And, we often find problems in the simulation which we go back and fix. But, this kind of stuff happens repeatedly. We create millions of images, hundreds of movies, to kind of assess what's going on. And, all these things are fairly small, and they're consumable. And we need to create an infrastructure where these things can be reviewed. And earlier I would do these things, and I'd, create web pages, hundreds of them, and open them. And they said, it's great, but can you put an access control on them? And I said, well, I can't, because that's a different sort of problem. So now we can actually. We can set up these boxes, have a very generic infrastructure to deal with these sort of problems. Yeah.
And does this also relate to public access to publicly collected information? I've been hearing this around the lab, kind of murmurs about, we're going to have our data has to be accessible.
So, absolutely. So there are different initiatives happening around the world, including US, where there's an open data mandate that anything funded through federal dollars or federal funding needs to be open after the conclusion of research. And so NIH is sort of one of the leading agencies in the United States, which is mandating that the publication should be made free after a year of embargo. So the journals can keep it under control for 1 year, but after 1 year it should be available to public for free. Similar things are happening not just for the publication, which is simply a PDF document generally, but also for the data. All the data needs to be made publicly available. And NSF also, which is the National Science Foundation, which is funding this project as well, they also have a similar mandate that each project needs to come up with something what they call a data management plan. And the research or the data which comes out of any funded work needs to be made available to the public at least for some duration. So, you know, there is no fixed duration which is set, because NSF is going about doing these things in different ways than NIH. NIH is creating their own repository where people can go put their stuff. NSF is going in a different direction and saying that you need to figure this out on your own. And so, yeah, so our role here is to kind of enable that sort of thing. And I think we are also looking at a very, very interesting example is, you know, we work with a lot of scientists and researchers around the country, and they have, you know, students and postdocs and other people who do fantastic work, but they leave after a few years, right? And they drop a hard drive into the PI's desk and says, okay, here is my work. The next student comes in and looks at their hard drive. Well, good luck figuring out anything, right? So if that context is missing, you cannot figure that out. But if you can capture that content from the get-go, now all that information becomes reusable for other people who may be interested in that sort of thing. All right, I'm done. All right. All right. Well, thanks for coming, guys.
So I think I'm contributing, on Friday I'm doing the sprint for the first time. I've never done that, but I'm not really a coder. I mean, I code a little bit. I was thinking of doing something more like QA. So I think I will do some work practicing with your, you know, I'll do something on your seed thing. And so if you want, we want to talk.
Yeah, let's talk. I'm not here, unfortunately, on Friday. I'm leaving tomorrow, but we can talk, yeah.
Well, I mean, I think I can just go up and do the kind of things I would imagine doing. And,
so what do you have in mind?